we're going to get started with the second talk. So our second talk today is an overview of MongoDB and also a demo of Atlas. We have Girish here, who is a senior solution architect from MongoDB, and he has about 15 years of experience in enterprise space. And he also is coming actually from very far away today. So I'm really fortunate to have both the speakers who have taken the time to come here and present on these topics. Please welcome Girish.
Hi everyone. So before I begin, just a quick show of hands. How many of you are familiar with MongoDB? Okay. So I was given a chance, to come here and give a quick talk MongoDB, and I thought, this would be one of the few chances I ever have to talk about MongoDB at Oracle. So definitely interesting, not something I'm used to. But actually, more interestingly, how many of you actually work at Oracle? Oh, okay. This is going to be great. This is going to be fun. Have you guys ever seen a MongoDB presentation? No? Okay, this is fun. Go easy on the questions though. But okay, let me get this started. But I think the goal here today is really just to talk about MongoDB in terms of what a document database is about. How to think about it. It's a very different thing. I mean, just to give you some background, I actually was developing using Java 1.4, Hibernate, Spring. I worked for Spring Source for a while as well. I went into the LAMP stack, and then at that point, with Java, the database we used back then was Postgres, and then with the LAMP stack, obviously I used MySQL. So I've been a relational guy my whole life. Even in school, we had to draw ERD diagrams and things like that. So I was hearing about MongoDB, and then eventually we came to a point where people started talking about the mean stack. And I was just comfortable with the LAMP stack. I was kind of interested in it, and now it's like maybe even the MERN stack. How many of you are familiar with the mean or MERN stack? So it seems like a lot of you are developers here, but the interesting thing is learning more about MongoDB. I found it very interesting that it's not an either or. I mean, in terms of database, I'm sure you can use one, but I don't think one's better than the other. I think what it really comes down to is that it's just so different how you think about just modeling everything. When you draw an ERD diagram, you think of all the objects first, and then you think of the relationships. With MongoDB, anytime I do a data modeling exercise with anyone, the first thing I ask is, what are your queries like? Because that's all we care about. Your objects could go into a single collection, multiple collections. It all depends. There's no right way to do it. It really depends on what are your queries. So, and speaking of, just most of you are familiar with MongoDB, like, when was it? How many of you used MongoDB more than 5 years ago and never touched it ever? Okay. For the most part, that's what I see. People just dabble in MongoDB when it first came out, and then after a while, they thought it was a niche database. And it's just what you use at work is a relational database. So this slide is just interesting for me because it tells a whole story. Back in the day, with 3.0, or even before that, we used to have a storage engine called mmap v1. It was pretty simple. Elliot, who's the CTO, he wanted to build a database. He said, let's use memory mapping that the OS provides. So you literally bring all the files from disk, put them in memory, and then that's how you access all your data. We used to have database level logging. So as you're reading and writing to a MongoDB database, that's all you could do, just one request at a time. And then they kind of tried really hard to get mmap working better. And they got down to a collection level locking, which is table for that matter. But even then, that's pretty horrible, right? So that was MongoDB 3.0. What they did was they introduced some APIs where you can just plug in storage engines. We were experimenting with things like RocksDB, and WiredTiger came along. There's this company in Australia. They said, hey, we just finished building against your API. Could you test our storage engine out? We liked them so much, I think we acquired the company shortly after. 3.0 was the first version of MongoDB where we had two storage engines. mmap, which is what we start with, and then WiredTiger. 3.2, WiredTiger became the default storage engine. That's how quickly we knew whatever mmap was doing was just not the right way to go. So the only reason this slide is fun is because there are a lot of people who actually know MongoDB from back in the day, 2.6, 3.0. it's just good to give a bit of perspective. That's what MongoDB was back in the day, 3.0, working really hard to get the storage engine right. Where MongoDB is right now, the features that they're adding, if you think about it, is really just targeting developer productivity. MongoDB query language, just how do you scale it, and just how do you just focus on actually writing your application. Before I go on, any questions? Is anyone who's familiar, if you do know a bit of the history and you want to ask anything? No? We're good?
And you still use the white tiger now?
So White Tiger is, as of MongoDB 4, it's the only storage engine we have. White Tiger, and then we have encrypted White Tiger and in-memory storage engine as well. But yeah, MF v1 is gone. So you can imagine, right? Most of you work with databases, even migrating from version 2.6 to 3. It's just a very painful time 5 years ago. So it's just something we like to call out right as we start. So 3 things, very simple. The reason why it is one of the more popular databases on Stack Overflow is that it's just easy to work with MongoDB. If you think about it, in your application layer, you're dealing with objects. It's not that natural if your objects end up in 15 tables, right? So you're working with a person, he has addresses, maybe a couple of offspring, siblings, or something along those lines. For that to end up in 15 tables, and then for you to have an ORM layer in the middle, just to do the conversion. It's not, it works. It's how we've been doing it our whole lives, but it's not natural. It should be a document. It's like if you were to retrieve a patient record in a doctor's office, are you going to open up 3-4 cabinets, get papers together, and then put it together and be like, okay, I understand what's going on with the patient now? No, you're probably just going to take a single document and it's all there. So based on that concept, that's why MongoDB, it's easy. The way you visualize your object in your application, that's how it's stored in the database. It's fast. We're not reinventing physics here. That's really not, there's no dedicated hardware MongoDB runs on. It's fast for the simple reason that data that's accessed together is stored together. And once again, I know some of you might be thinking like that doesn't make sense at all because some of the objects you deal with might be like 50 megabytes or something like that. So, if you have questions around that, we can definitely address that as well. Does it make sense to really just put all the information of a certain object in a document? It's flexible in terms of just allowing you to create different documents in the same collection. Like how many of you have started out with a new application, you have a data model in mind, a year later, some internal department or your customers ask for like, hey, can we also capture these things in the database? And then now you have to write an alter table, you have to change, you have to regenerate your ORM XML files. I don't know how ORMs work now, but I'm talking from my Hibernate days. But I know I used to like regenerate all the XML files. But that's just because someone wanted to add a field. So MongoDB, just create a document. You want to add another field in there, just go ahead. If tomorrow you decide to capture someone's blood group, just put it in there. It's versatile because there's really no point in storing all this information if you can't ask questions about the database. In the sense that if you're going to put geospatial data, you need to be able to query geospatial data. If you want to put key value, you need to be able to do that as well. I'm not going to touch a lot on intelligently put data where you want because a lot of it really has to do with people who are in ops. Are there any DBAs here? No? Okay, so it wouldn't make sense for me to just go into the fact that you can shard and there's workload isolation and things. Let's stick to what makes it appealing to developers. Freedom to run anywhere though, a little important. With what's coming out right now, all these managed services, we're getting used to it. Now we don't have our own data centers. Even when it comes to databases, we are relying on managed database as a service. It is really important that when I download a software and install it on my laptop and I'm coding against it, and then maybe I put it up on staging where it's self-hosted, maybe AWS, GCP, or Azure, to maybe when I go to a managed service, all my code has to run. I cannot be writing code on my laptop only to put it in production to realize that the version of the database in a managed service is different from the one that's running my database. So MongoDB, whether you're running a laptop, your own data center or MongoDB Atlas, which is our managed databases service, it works the same. I spoke about this, I'm just gonna skip through this, I'm not gonna touch on. This might be a little relevant, only because I just wanna talk about the relationship between the relational database and MongoDB. So I think we spoke about the fact that tables are called collections. Parent-child tables, instead of putting two documents in two separate collections, what we do is we just nest them, or we embed them. That's an easy way of just doing a one-to-one relation. Indexes are indexes, rows are your documents, and more importantly, columns are your field. So we don't have to go into detail about this, but when I say collection and documents and fields, that's kind of what it maps to. Asset transactions, that was a huge thing as well. I think anyone who's written an application understands that there's never a time where you just work with one object. There's a good chance you might have to touch 4 or 5 objects, debit, credit, when you order something, you need to decrease the inventory, things like that. So you always will need to be making multiple queries or updates to your database. MongoDB was asset compliant on a document level, because that was the plan. You just put everything in a document. Hey, if you try to change data, it's all asset compliant within a document. Eventually it became a thing where it almost might be just a checkbox feature, I'll be honest with you. But starting with 4.0, MongoDB is asset compliant, very similar to what you are used to in your MySQL, Postgres world, or any other database. You start transactions, you execute multiple statements, and then you commit it right at the end, or you just roll it back. This is what I was talking about when I was talking about the flexibility. If you have a person like this, 6 months later, someone says, hey, can we also capture phone numbers? It's as simple as just adding in another field to your JSON document. Having said that, MongoDB is not schemaless, it has a flexible schema. There are times, it will be crazy for you to think as an application owner if you just, especially if you're building on microservices and you have MongoDB as a backend, just to imagine that people will be just putting all kinds of data in your database. That's not a comforting feeling. So MongoDB does have JSON validation for your schemas, so you can actually define hey, certain fields only have a certain data types that can be accepted. So it's not no schema, it's not schemaless, there's a flexible schema where you can set some guardrails around it. Fast, we spoke about that. This is something that's interesting. So, how many, when you, for most of you, when you've used MongoDB, what kind of project was it? I'm kind of curious, do you guys use it for geospatial data, mostly just key value, or some metadata, but you do your real work with the relational databases? Do you guys have any examples of what you've used MongoDB for in production, maybe?
XML files convert to JSON.
Just XML files coming from a data store and converting it, and then you just refer to when you query the XML files, do you just refer to it by an ID? That's it. There are no complex queries involved or anything of that sort.
Right.
Okay. Yeah. So that's funny enough. I see that a lot as well. It's just okay, let me just put this in MongoDB. I will always query it with a single ID. At that point, I think you can pretty much use any database, because all you need is a database that supports primary indexes. With MongoDB, what you're getting is the fact that you have a rich JSON document. You have a primary index, obviously, but you also can have secondary indexes, which are arrays, which is a nested document. So the data that you have now, you can search for it in different ways. That's JSON documents. If for some reason you want to store your data in tables, you can do that in a JSON document. Key value pair. Think of a time series database, IoT use case. You have the sensor sending out temperature readings every 3 seconds. It's really just key value, timestamp, sensor ID, and temperature. That's it. You can use MongoDB for that as well. Are there better databases for time series? Definitely. Right? If you really are building an IoT platform, then you want to get the best in class for time series. For graph databases, could you use MongoDB? There's a good chance, 80%, most of your graph queries, MongoDB will be able to do without graph operator. But that's the reason Neo4j exists. There's no way MongoDB will ever be able to compete with anyone who really needs a graph database. So if you see what we are saying here is that it's a JSON document. We give you various ways to query it. We're a general purpose database. That's it. So when you think of MongoDB, it really should be along the lines where, hey, do I really want to just use this best in class for a key value and another best in class for graph, or is the workload I'm doing just something pretty standard where I can just maintain one database? Is this good for you guys so far? Do you want me to carry on a bit with this and then go to a demo, or how are you feeling? I just want to make sure if this is.
Keep on going, overview.
I'm sorry.
Keep on going, overview.
Overview. All right. Cool. All right. I'll try to just quickly touch on things that once again I think are relevant. So we spoke about the multiple ways of querying data. I'm not going to touch on that. Indexes. That's another interesting thing as well. Primary indexes. We all know how that works. Multi-key indexes are what I was talking about when I say you can index arrays. Like, can you imagine just having a person with maybe possibly 4 contact numbers or 3 contact numbers or 2? Like, you're not really creating a table and saying contact 1, contact 2, contact 3, contact 4, and just having empty cells in the table. What you're doing is you just store them in an array, and you can just index all of it. So you're indexing the person who has 2 contact numbers the same way you're indexing someone who has 4. We did release something new, which is full text search. That might be something that's interesting. If you are, we can do it during the Q&A. But yeah, there are index types and then there are index features. TTL indexes, just real simple. Once again, time series database. If you want to use MongoDB as a time series database, just put your data in there, set a TTL for it to expire after 6 months, and then the data just gets erased from MongoDB after that. Partial index is another thing. When you bring data from a mainframe to MongoDB and you're like, okay, this is great. I just needed that data in MongoDB, but I'm pretty sure I'm never going to query it that often. And I don't want all of that data to just fit in my memory and use up my memory for indexes. You can just do a partial index where you say only data that's 6 months old, just index that. Aggregation pipeline. Just once again, show of hand, how many of you are familiar with the aggregation framework, MongoDB? Used it before? Okay, a couple of you have. So the aggregation framework pretty much works like a Unix pipe. You do something, you pipe it, the output of the first stage goes to the next one. That's really it. You match a couple of documents, you group them, and then you sort them or something along those lines. There are a lot of stages that we have. I think Dipti was asking for just some, just for me to dive in a bit more into the lookup. So lookup is MongoDB's version of joining collections. So you can get a document from one collection and join it with a couple more. It's interesting because anyone who uses MongoDB, they're like, wait a minute, you just told me to put all my data in one document. Why would I ever need to join one document to another document? That doesn't make any sense. There are cases, obviously, where you will have to do it. So I have a couple of slides on lookup as well. I'll just touch on that real quick. But the aggregation framework basically is our version of letting you use MongoDB in a better way instead of just querying querying for the primary key. You have data in there that's rich data. You need to be able to run analytical queries.
I have a question. So, why don't they allow a SQL kind of structure instead of learning something which is very different?
That's true. Yeah, I mean, we do have a BI connector, which will allow you to execute SQL-like statements on MongoDB. It cannot be the most efficient way to query MongoDB, but I think one of the reasons you cannot use a SQL-like syntax to query MongoDB is because it's not a relational database. Like, a lot of it is just not relevant. I guess maybe you're asking, why don't you just do a group by or something which is similar? For the most part, it is. I think even when we name it, we try to be careful. We try not to do something crazy. There are a lot of things that MongoDB has to support that a relational database does not. Like, if you look at unwind here, this is basically a aggregation stage where you say, if I have 5 addresses in an array, unwind them. So you split them up. So you can basically now split up 5 addresses, link them to a zip code, you know, or like whatever it is you need to do. But how do you work with that array? You need to add another pipeline stage. So, but to answer your question, I think this is what a SQL statement looks like. And if you really think about it, I know how to read this. Like, this is what I grew up doing. But if I asked you to figure out what's going on here, you're like, okay, I get this. I'm just going to go to the middle here. I see this selecting an address, and then I'm going to work my way out, and then maybe I'll finally understand what's going on here, right? I mean, it's what we're used to. Don't get me wrong. There's nothing wrong with this, but once again, not natural. You're starting in the middle, and you're reading out just to understand what this statement does. This is the aggregation framework. Customer collection, unwind all my addresses, match address that says home, group it by a city. Stages, they just go. Same thing, or, I mean, not exactly the same thing, but actually it is. This is the same query. This is in SQL and this is in aggregation framework. Like, where would you even start to understand this? And imagine SQL statements or PL SQL statements or triggers that people have written like 3 years ago. And it gets complex. It gets really complex. So, not good or bad, but I think you're starting with, I'm sorry?
His question is, it's complex for pure SQL developers and maybe SQL developers to use MongoDB.
Definitely. There is definitely a learning curve. And I think it's one of the reasons people don't use MongoDB for anything more than just retrieving stuff using primary key. Right? Because if you think about it, this is an aggregation framework, you're like, wait, what is this whole aggregation framework? I have to learn a new way of doing things. I'm like, no, you're doing it the way you're supposed to, you know? Top to bottom, you know?
So my question is really, is there going to be a feature introduced where they can have an option to use SQL and stuff? This is good too, by having an option to use SQL as well.
We did have a Mongo MySQL D service running, but right now the only time MongoDB will really cater to that would be for reporting. Because if you think of the Tableaus and just any charting software, there's a good chance that those people are not moving away from SQL, and we have a BI connector. But I'll be honest with you, if you are doing a really complex report, I cannot imagine using a computer as efficient. Like, I mean, we all know how that probably works. It's mapping to something that you think, okay, this is probably what the SQL statement is trying to do. But if you were to think about that from a Mongo point of view, you would have done it very differently. So yeah. But yeah, so BI connector, that's probably the only way you can ever query a Mongo database using SQL today.
Quick question.
Yeah.
Back to this, how does this compare to like N1QL Couchbase, for example?
I'm not that familiar with that though.
Because they have something similar where you could, it's a SQL-like query language for document databases. So I'm just wondering if there's a comparison to that.
Yeah, I wish I actually had some context, but no. What's that you said
It's
again?
called N1QL,
Okay,
which is like a query language for document databases.
I will read up on it, and maybe hopefully if I'm invited back, we can talk about it. But, yeah. But okay, that's interesting. I'm not sure how it is, but I think that's it. Couchbase, newer database, coming up with your own query language. That's what's going to happen. You're not going to use a query language that was good 40 years ago. Once again, that's just nothing wrong with SQL. It's just if you're building something from scratch, you know how developers will always be like, no, there has to be a better way. We can't be doing what we were doing 40 years ago. So, but just real quick, how are we doing on time here? Okay, I know I'm standing between you guys and going home, but we spoke about this. MongoDB, inherently, it's highly available. You never deploy a single node of MongoDB. It always at least is a 3-node cluster. That's a primary and 2 secondaries. You can have 5 nodes, and when you do so, what you're doing is your application is still writing to the primary. You will always only write to the primary. That's why we will never have consistency issues. If you ever try to do a master, and this is the conversation I get into all the time. Everyone I talk to, they're like, hey, but why can't MongoDB do master? I'm like, you deal with a whole other set of problems when you ever try to have 2 databases that are active or master. MongoDB, when you deploy it, you only write to primary. That's it. Secondaries are literally there just for high availability, not for scalability. If you want to scale in MongoDB, you shard. You don't deploy more nodes in your replica set. More nodes in your replica set, though, however, can help you with throughput because you can actually assign 2 nodes as analytical nodes. So they are literally there just for your charting or BI tools to run long-running queries on.
How do transactions work in such a scenario?
So transactions, for the most part, when you're looking at transactions, you're looking at inserts and updates. It's all happening on the primary. I could have 15 nodes here. I'm only touching 1 node for updates and inserts. Yeah.
So if your primary goes down, what's you have something in second, there's going to be some gap between secondary and primary, so we can lose data?
You would not lose data. The driver has retriable rights and reads built into the driver itself. And the election takes place pretty quickly. There's a heartbeat that gets sent between all these nodes. So when a primary goes down, the secondary gets elected right away. But you're right, it is not right away. There is a gap in there.
Seconds?
No, I think you're looking at milliseconds to maybe 2 seconds. Yeah, and that's why you have high availability. And once again, this is really interesting because this is it, right? This is not, oh, let me get MongoDB and let me figure out how to replicate data from my primary and secondary node. That is how you deploy MongoDB. It's a 3-node replica set always, yeah.
What happens if there's a network partition? Do I like have a leader in one of the clusters?
Like if you had like multiple nodes across different regions.
Now let's say I have 5 in that replica set, right? And some reason the network is split. Now only 2 are able to contact each other and 3 again. So do they elect their own leaders now? And they come back together? Or how does that work?
So for an election to happen, you need majority. So I'll show you in Atlas, when you deploy replica sets in Atlas, we only allow you to deploy odd numbers because it really doesn't make sense to deploy even numbers of nodes. So to answer your question, if there was a network partition, if they lose majority, those 2 nodes are out of commission. So your primary is still your primary. Firstly, no election needs to happen, right? So your primary is still your primary, except if your primary is on the other data center where there are only 2 there, and then now you have 3 here. So yes, there'll be a primary that is elected here, and these 2 will just they'll stop working.
Okay. And what happens in between that election? I write something to the leader in the first partition. The second one doesn't have that view. And now I elect a leader there. This one goes down. He's not the leader anymore.
Yeah.
I mean, I'm
No,
getting
that's a great question. No, I mean, this is exactly, firstly, you're wearing our Oracle shirt, so I was like, kidding. I was like, well, if anyone's going to ask me a hard question, it's probably you. But no, but that's a great question. I actually don't know the answer to that. I know it's obviously something we've thought of. And the reason I say this is because nobody deploys all 5 nodes in a single region. The reason we allow people to deploy multiple nodes is that for the most part, it's always split between 2-3 regions. So you're absolutely right. And if you talk about network partition or any network failure happen, there's a higher chance of it happening between regions. I don't have a good answer for you, like what happens if that write goes in. And that's the most important thing for any database, right? Just loss of data.
By your own statement, it shouldn't go in because as soon as it discovers that it's a 2 node out of 5, it's no longer master and it won't stay primary anymore.
I wanted to say that.
But that's my thought of how it works. Yeah.
Yeah, I wanted to say that, but then I know there's that split like 500 millisecond.
I'm not wearing the MongoDB t-shirt either, so.
No, but I mean, like you would think, right? You're like, oh well, I guess your write wouldn't go through, but it will. You know, there will be a time when that those 2 nodes, the primary actually thinks it's still the primary. So 500 millisecond, 200, whatever it is. But this is the exact kind of questions that people have because they're like, it's not, network blips happen all the time. So this is not a, well, once in 10 years if you lose a document, who cares? No, this probably would be pretty often, yeah.
Just recapping to what you just mentioned about the secondaries being not too many, what if in a highly scalable system, if I need a whole bunch of secondary nodes for reads, you did mention that there's going to be very common use cases are probably not many secondary nodes. Am I right, or did I get that wrong?
If you want a high throughput for read, there's a good chance you will
Not use Mongo?
Actually, no,
Google
back in
and
the
Facebook are not
day.
using it, so.
Yeah, well, I mean, yeah, they're probably building their own. I mean, they're not. Yeah, that's a whole different thing. No, you're right. But if you want a high throughput for read, you would use sharding. I think that's more. That's probably the better pattern than versus creating multiple secondary nodes, possibly having stale data in your secondaries, and then having to worry about that situation. Because once you shard, what you're doing is you're setting replica sets of 3, 3, 3, 3 in 4 shards. At that point, each replica set has its own primary. So you're writing to the primary, but sure, you can then read from the primary as well, because now your primary is not really, the write load itself has been split across 4 shards. So that's any kind of scalability, throughput, I would achieve it through sharding, not through adding multiple nodes.
Your sharding means you mean splitting into multiple packages based on some
Yes.
index.
Data partition, yeah, data partition using a shard key. MongoDB allows you to shard data using hash, which is what most people do. It's very random. It does not make a lot of sense for some people, or by range, or by tags. So range could be something as simple as, let me have 52 shards, 1 for each state. That could be a range. Tags could, yeah, I guess that could be a range or a tag. Range, I think, would be more like, well, let's think about this. If you created 2 shard, one running on high performing machines and the other one not, I could have a range of all my customer IDs who are free customers going to a different shard, and then the paying customers go to a different shard with a beefier machine. You know, like sharding in that sense, not just, so it's to achieve throughput, it's also to achieve, you know, just some kind of data locality as well.
So, for example, the one you said 52 states, you would have about 156 nodes, 156 instances, because you have 3 each.
Yeah. Oh no, I mean, there are people who have done like 600 nodes of MongoDB. Yeah, like Fortnite uses us. It is just insane. The deployment that they have from MongoDB is just crazy. Yeah, I mean, there are so many people, Fortnite. Even Cisco uses us for the e-commerce thing. It's pretty beefy. Yeah, I know it feels like, wait, 156 nodes of MongoDB, but you know.
So you said for transaction stuff it goes to the primary. I'm wondering if the driver is smart enough to go to the secondary for a read or for.
You can set a read preference on the driver. So you basically can tell it when you're executing the query. So if you're doing read from a BI tool, you would specify your read preference and it would go to a secondary.
Is it able to discover the topology as well? Or do I have to explicitly say go to this secondary node?
It will know which secondary it is. It will know which secondary it is. In fact, even your connection string, back in the day, what we used to do is we used to put like all 3 or 5 nodes connection string with Atlas, and I'm pretty sure you can do this yourself too, it's just DNS. You can use an SRV record as well, like a service record, and at that point you just have one URL, so even when your primaries go down or anything of that sort, your application just always has that one URL. And what you're doing is adding in a get parameter saying read preference secondary, and that's how it knows to go to another node. Awesome, so we spoke about locality as well, that's another thing, sharding. I'm not going to go and look up, I think this might be a bit more, you know, like, hey, when do I use joins, when do I shard, like, it'll be one of those discussions, so, but we have the ability to join collections. Chain streams, is this good enough? Do you guys want a demo or just carry on going with this? Anyone's just like jonesing for a demo? I don't know. Somehow I feel like
Are you
people
jonesing
up.
for a demo?
Oh, I prepared it. No, I'm kidding. Yeah, all the 20 minutes I put into that. But no, I mean, if you guys want to just stick with this is awesome. Like, I love talking about this stuff. So, everyone fine? Okay, cool. Chain streams. So this is interesting because now everything is about real time. So when, I'm sure a lot of you have questions as well, like where's the trigger in MongoDB? You know, if something happens to a record, how do you execute some kind of business logic? The difference is that MongoDB does not execute the business logic on MongoDB. What it does is that it has a chain string, so there's a connection that's open MongoDB. WebSockets is every time a document changes or is updated, and you can select. So it could be something like, hey, if documents inserted where the temperature is higher than 75, then send a change stream out. Where the temperature is, so if you're monitoring like IoT devices when a document's inserted, you can actually send a change stream out to an app server, any Node.js process, Java process, and then you have your business logic there. I kind of like it because you're separating, you're not making your database do more work because documents are changing more frequently. You're actually decoupling that and having all that business logic on your application server. And the change streams is how we work with Kafka as well. We can be a source for Kafka, and that's how it works as well. We have a Kafka connector where we can be used as a sink as well, but for the most part, change streams is what allows us to be a source. Not going to touch on intelligently put data because although that is most of the questions we've had so far, but it's usually more for like DBAs get really excited about this, but I think we spoke a lot about high availability workload isolations with a secondary node, scalability with sharding, locality also with sharding. So I'm just going to jump through this whole thing. This, I kind of touched a bit on this. So bottom line is, if you use MongoDB, if you use a driver, Node.js, Java, anything, it should work the same, whether you're coding against MongoDB community on your laptop, MongoDB Enterprise when you've posted it on AWS, or MongoDB Atlas if you decide to get a managed database as a service. That's Atlas. I'm not going to go into the whole marketing thing. I think a lot of you understand what a managed database as a service is, so this is pretty much, I think for the most part, just a marketing slide. I'd rather just show you the demo.
So I had a question on Atlas.
Sure.
It doesn't allow you to use APIs to interact with the database. You know why?
With the database?
I couldn't update documents using APIs.
No, there is no HTTP or REST interface to interact with the database. If you want to interact with the database, we do have, that's not even specific to Atlas, so I can just say MongoDB REST API. That's a whole ecosystem of, right? I mean, you wouldn't do it through Atlas.
There's something, it doesn't allow something. I think it allows read or something, it doesn't allow update, something. It has some issues.
So Atlas APIs are really just for managing your clusters. Like that was,
right.
yes,
That's right.
100%, yeah, because it's Atlas. The APIs are meant to manage your MongoDB cluster. It's not meant to manipulate your data.
Well, why not? Why can't we provide
And,
that?
but imagine if we did, then the way you work with MongoDB and Atlas is going to be different from the way you work with MongoDB elsewhere. Part of it is the whole freedom to run anywhere. We're not going to create a HTTP interface for the data, especially when you actually have ways to do that with any MongoDB community, MongoDB Enterprise, MongoDB Atlas. This page here will give you all the steps on how you can manipulate data in MongoDB through a REST API. Atlas is more for the management, automation, backup, monitoring, not so much a new way to interact with your data.
I was trying to avoid using a driver for MongoDB because it's JSON anyway. I was expecting the REST API and just giving it just on the back end.
Right.
And that would install the driver and delete the drivers, but it didn't work well.
Yeah. So you tried doing something in Atlas and you're like, okay, can I just make a HTTP call and add a document? Yeah.
I saw the HTTP interface attached, that's what it's meant for, but as you said,
Yeah.
it's
No,
meant
it's
for managing the Atlas, not for
it's admin APIs, right? Monitoring, building, this, that. It's what you would use if you had Kubernetes, and for some reason people are running databases on Kubernetes now as well. I think, I'm sure you have a lot to say about that, but I guess persistent volumes kind of allow for that now, allow you to actually run databases on Kubernetes. So if you were to have Kubernetes, so like open service broker, I think, that's what you can actually use open service broker to interact with the Atlas APIs to spin up a cluster, spin down a cluster, add more nodes, or you can use Kubernetes and Ops Manager API. So yeah, but yeah, no, I agree with you. It's confusing. Like if you have APIs, why can't I manipulate the data? But it's really for management of your cluster. That's awesome. So we have some of you who have played with Atlas too. This is gonna make it easy. So this is MongoDB Atlas. The UI you see here is going to be the same UI you see if you used Ops Manager with MongoDB, if you use Cloud Manager. So if you had your own version of MongoDB installed in AWS, GCP, or your own data center or Azure, you could use something like Cloud Manager or Ops Manager to get the same metrics that you want from a database monitoring tool. Same UI, same code base. So we are basically running the biggest installation of Cloud Manager by managing all our Atlas clusters. What you do is, when you build a new cluster, you have the ability to choose which cloud provider you want. I think that is something that we really believe sets us apart, because we really don't want to be tied to a single provider. There are certain differences based on the cloud provider. Like if you use AWS, we allow you to choose like an NVMe disk. With Azure, it's not so much. The IOPS is pretty much tied to the disk size. But for the most part, you are used to the nuances for the cloud provider, because there's a good chance you have your app server running there too. So if I just choose GCP, US West 2, this is what I was talking about, where I said I could add another region and I could actually deploy MongoDB nodes, like 5 nodes separately. And if I try to do something like this, it tells me I can only do odd numbers. But this is for high availability. Eventually, read-only nodes, analytic nodes, you can have a couple of them as well. Yeah.
Can you do cross-cloud deployments? Okay.
Coming soon. That is something a couple of people have asked. I think now everyone's afraid of cloud providers getting
Locked in?
well, I mean, the lock-in thing was always there, but then if you have the cloud, like Target would never you host on AWS. You know, like it's just not something they would do. But you just don't know that is coming too, you know, for the most part. So the whole idea is that people, I see it more now, people doing this whole cloud, cross-cloud provider strategies, you know, versus just putting it all in one. But yeah, it's coming soon at some point.
And this, okay, so this is a managed service, so customers can't specify their own AWS accounts or GCP accounts, and you go from there.
So because we have to manage it, because we have to do the maintenance, upgrades, and things like that, what we do is we provision this cluster in our own VPC, and there's a VNet peering or a VPC peering. For the most part, it works. I think there's only one company I've spoken to where they're like, no, we can't even peer it. It needs to be in our VPC. I'm like, I don't think you can embrace cloud totally, but yeah, you know, like that is the whole idea. You just have VPCs and you peer it. That should be as secure as a private network. I don't know. There must be something I'm missing there, but yeah. So that's how it works today. You basically, there's a good chance if you're running AWS, you have your own VPC. You'll peer it with ours. So yeah.
I'm wondering how that works with, because VPCs I believe are regional, right? And if you have multi-deployment, multi-region deployments.
Yeah. Not supported yet. Yeah, you're right. Exactly. If you had US East, US West, you know, that VPC peering would be a much more challenging thing than a single region. I actually, as part of like something I had to do this week to read up more on that as well. But for now, I guess what I can leave you with is I mean, MongoDB, it can be multi-region. There is VPC peering. Whether you can do both of that together, you know, I'll have to do some research, and hopefully it's just out there, public information. It should not be something that's too hard to find. There's another thing I'm going to talk about. Okay, let me just go on with just creating this. But here you have your multiple nodes. We have our own definition of what an instance is, but I mean, if you know this, it really maps to what the cloud provider is providing us. You know, whether it's a EC2 instance or a GCP compute instance. So additional settings here. This is how it works. You get to choose what major version of MongoDB you want to start your cluster with, and you get to come back here 3 months later and upgrade it to a different version. There is zero downtime. Everything is done in a rolling fashion. That's the reason we have multiple nodes. You just update the secondaries, you step the primary down. An election happens, sure, 400 milliseconds of downtime, but that's how you upgrade a version of MongoDB. And the maintenance updates, like MongoDB does it for you, MongoDB Atlas does it for you. You can specify a time when you want those maintenance windows to happen. You don't want it to happen right in the middle of Black Friday if you're like a Macy's or Cole. So you get to tell Atlas when you want that to happen. Sharding clusters here, not going to go into that, but it really just allows you to define how many shards you want. Finally, we started talking today about WireTiger storage engine, and the fact that we have an encrypted storage engine as well. So if you do decide to encrypt your data at rest, we allow you to use, KMS or Vault to manage your keys. I'm not going to create a cluster because it'll take 7 minutes. I actually was supposed to run this just to show you guys something, but let me do this real quick. I might still be able to talk for another 4 minutes. But I'm just running some really horrible, inefficient query here, which is really just searching for everything that's not indexed. And the reason I'm doing this is because I just wanted to show you guys Performance Manager. But before I do that, let's talk about alerting. Is this good enough? Like, just in terms of what Atlas is, multi-cloud, best practices are built in, the VPC we provision for you, the VMs that we deploy on, they're all tuned for MongoDB. So it makes sense. Alerting, at the end of the day, and this is not just for MongoDB, like any company I've worked for, when we have an on-prem version and a cloud version, the amount of conversations that surround just like monitoring, alerting, visibility in the logs, and this, like everyone feels like anytime they go into a managed service, they lose some power. They lose like some ownership of their database. But and that's why I guess what I'm trying to say is that the good thing is that everything Atlas gives you is what you would have gotten in Ops Manager or Cloud Manager if you were managing your own instance of MongoDB. Sure, you're not going to be able to SSH into the machine. Like, you just hope it never comes to that, and I know it doesn't really work that way, but you actually can generate a token and get the support team to be able to SSH in if it ever comes to that point. It's really like not something I see happen. I haven't seen it happen yet. But alerts, just wanted to touch on a couple of things. This might be interesting for you guys, but you can just do something like host of any type. Just do something like, and I'm sure this is what you expect from every managed database as a service, so I don't think this is something specific in MongoDB, but you could have something like just any query that runs for more than a minute. You can have an alert go off, and you can get it in various ways. The bottom line is this is something you can, building a cluster, really the steps I took you through, that is how you build your own cluster. If you want to just sign up for a free cluster, MongoDB has a sandbox, just get started with that. And it's, basically monitoring, alerting, it's all there to be able to satisfy you at a production level. I think that's what I wanted to touch on. Database, I'm not going to get into security as well, just because it's pretty typical. I think security, for the most part, as far as authentication is concerned, is table stakes now. But I did want to touch on this if I can. I go to my cluster here. I go to metrics. These are the metrics. So you get two kinds of metrics, right? One is hardware metrics, which I guess if you were managing your own MongoDB, any ops person worth his salt would probably be able to get you all these hardware metrics. We give you a lot of MongoDB metrics as well. So this is something that's tool for you instead of you having to run like a top command and just see what's going on. Performance Advisor, the last thing I'm going to touch on, if this works. There you go, perfect. So this just happened because I kept on running this slow query. So imagine how powerful this is. We spoke about how different it is to model for data modeling for MongoDB. It's not draw ERD diagrams and think of the relationships. It's, do I put all the data of a person in a single collection, multiple, like how do you do all that? Once you get the hang of it, it's actually easy, but what we have is tools to just help you. So if you did model your data in a certain way and you have an application that's just hitting your database And we actually give you like things like index suggestions, where we're like, hey, we had about 46 executions in the past 3 hours. Average execution time is 1.3 seconds, and it's just really inefficient. So you get to just go here, copy this, and create an index. Yeah, I mean, that really is not the power of it. I think the power is just that whole suggestion, or just monitoring that, hey, a query is taking too long, and there's something you can do about it. Yeah, so I think this is what I wanted to show you in terms of Atlas. I mean, I could go on for a while, but I'm just going to save the next couple of minutes for any questions.
Can it do stuff like create indices automatically and for the query to improve the performance?
Nah, you'll have to rely on like alerts and things like that. If we ever start creating indexes for people automatically, that'll be.
No.
Can you feed this into your alert system so that, then you could,
It can
you
create
could have,
index
you could
for you.
effectively have this alert comes in, runs this
Yeah.
automatically.
I mean, you
against the database.
you can monitor your email and then run like a script and create an index, I guess. Oh, I actually don't know. I actually do get an email for every long-running query. I just don't think the email really gives you this. Though.
Okay.
Yeah, that's interesting though. Would you ever want anyone to create an index for you automatically? That's the real question. MongoDB 4.2, by the way, does have a new way of creating index. Back in the day, MongoDB, there were two options, background and foreground. Background obviously doesn't really affect your operational workload. Foreground is super fast, but locks up your whole database. We don't let you choose now. MongoDB 4.2, you just build indexes. What's happening under the hood is they're literally creating a copy of the collection, creating the index, and then somehow catching it out and finding out the new databases. So there's no concept of foreground or background index build. The database doesn't get locked up, and you still get the speed that you expect from a foreground index build. So technically, maybe, yeah, you could automate building indexes if it's not really going to affect your operational workload. Yeah, any other questions? Yeah? All right, thank you guys.